Hello everyone, welcome to my YouTube channel. Let us do self-study. Today I am discussing coordinate geometry from class 9th and my reference book is NCERT. So how to locate a point in a plane. We have already studied how to locate a point on a number line. So in one dimension we have a point on a number line. On a number line we say a point is 3 units away from 0. A point is minus 3 units away from 0. Likewise, in a plane, we need to say a point is 2 unit away from x-axis and the point is 2 units away from y-axis. So you must be wondering what is axis, x-axis, y-axis. So just try to locate a point in a plane. How will you locate a point in a plane? So what is a plane? We know this is a number line. So number line is one dimension. And what is a plane? Like a top of the table is a plane, a playground is a plane. So if you have been told that locate this point on the plane, so how will you locate this point? You will say, okay, so this point is x unit away from its left edge and y unit above the bottom line. So if we have two information, how far it is, this point is from this line and how far it is from the bottom line. So if we have two information, we can uniquely identify this point. If we say the point is this much distance away, like t unit away from the left edge and m unit away from the bottom line. So you can uniquely identify this line, this point. So to uniquely identify a point in a plane, the plane is what? A playground is a plane. Your tabletop is a plane. The floor is a plane, right? The city is a plane. A city can be a plane if you see in there is all the heights of the city is same. Then that is a plane. So this is two dimension. We have learned with the one dimension, that is number line. Two dimension is plane, and three dimension is building, where we have length, breadth and the height as well, that is three dimension. So in the coordinate geometry in your syllabus we are only discussing two dimension. So likewise there is a point 32. So this point 32 is 3 units away from y axis and 2 units away from x axis. So in the x direction, in this direction the unit is 3 and in this direction the unit is 2. So this is 2 units away on the in the y direction and 3 units away in the x direction. We generally denote this as x axis and y axis. This is what you will learn further as well. Likewise, this point is on the left side of the origin. We call this point as origin. So from origin, this is minus 2 points away and plus 2 units above this line. So in the x direction, this is in the negative x direction, and that is minus 2 units away in the negative x direction and 2 units away in the positive y direction. We will further discuss all these points whatever I am telling. Likewise, this is minus 3 units away in the minus x direction and minus 2 units away in the minus y direction, negative y direction. So this is in the negative x direction and negative y direction. Likewise, if we have 2 points in a plane, we can see how much is the distance between these 2 points. So one point is 1 1 and another point is 3 2. So 1 1 is it is x units, 1 unit away in x direction and 1 unit away in y direction. And 3 2 is, this point is 3 units away in x direction and 2 units away in y direction. So you can see this is becoming a Pythagoras right angle triangle, and we can use Pythagoras theorem to find the distance between these 2 points. The dot is 5 centimeter from left edge of paper and 9 centimeter above bottom line. So this is how we locate a dot on a paper. You take a paper and I say that the dot is 5 centimeter from the left edge of the paper and 9 centimeter above bottom line. So by telling this, we can uniquely identify the point on the paper. To find position of dot on paper, we need two independent information for finding the position of the dot. Like if I say that the point is 5 centimeter from left edge, if I say only say that the point is 5 centimeter from the left edge, so 5 centimeter from the left edge is all these points. Just the point is not unique. The point, there are all these points on this line, on the green line, all these points are 5 centimeter away from the left edge. This is also 5 centimeter. This is also 5 centimeter. So by only one information, we are not able to identify the point on a plane or a page. 9 if we say that the point is 9 centimeter above bottom line, so if all these points are 9 centimeter, all the points on the green line is 9 centimeter above the bottom line. So we are not able to uniquely identify the point with only one information. But if we say the point is 5 centimeter away from left edge and 9 centimeter above the bottom line, then there is only one point, only one such point is possible in the plane. So point is uniquely defined with two independent information, right? So the same way we can say, if we say that the point is 4 centimeter away from origin. So if we say the point is 4 centimeter away from origin, then the 4 centimeter is all the points on the circle, right? 4 centimeter from the center origin. If we say 4 centimeter away from origin, so we have all the points on the circle, that is 4 centimeter away from the origin. But when we say that the point is making this angle is making 45 degree, then this point is uniquely identified that this is the only point that is possible. So that the point makes 45 degree angle with the x-axis to the line segment that is joining to the origin. The point and the line segment and the origin joined line makes angle 45 degree from the x-axis. Then this point can be uniquely identified. So we will be using this information only generally, distance in the x direction and distance in the y direction. How will you describe the position of a table lamp on your study table? So we have come to the exercise. You try to do it yourself. Exercise 3.1. Then come back here. How will you describe the position of a table lamp on your study table to another person? So how will you tell where is the table lamp located on your table lamp, on your table? The table lamp, where is it located on the table? If you have to say something in mathematical form, how will you say him? So you will tell him, okay, so this point, the table lamp is x centimeter. We can say table lamp is x centimeter from left edge and y centimeter from front edge, right? So if you give him them the two information, that it is x centimeter from left edge and y centimeter from front edge on a table, then you can find a unique point where the table lamp is located. So this two information can uniquely identify the table lamp on the table. So this is the use of coordinate geometry. This is for what we study coordinate geometry. Okay, so there is another problem. It is telling that a city has two main roads which cross each other at the center of the city. These two roads are along the north-south direction and east-west direction. All the other streets of the city run parallel to these roads and are 200 meters apart. There are 5 streets in each direction. Using 1 centimeter equals to 200 meter, draw a model of the city on your notebook. Represent the roads straight by single lines. There are many cross streets in your model. A particular cross street is made by 2 streets, one running in the north-south direction and another in east-west direction. Each cross street is referred to in the following manner. If the second street running in the north-south direction and fifth in east-west direction meet at some crossing, then we will call this cross street 2, 5. Using this convention, find how many cross streets can be referred to as 4, 3 and how many cross streets can be referred to as 3, 4. So whatever is given in this statement, I will show you in the diagram. So the problem is telling that there are two main roads, that is in the east-west direction and north-south direction. So this red line we have denoted the main road. This is in the east-west direction and north-south direction, and both of these main roads cross each other at the center of the city, right? So in the city, this is the center of city, and these are the two main roads, and because these roads are in the north south and east west direction, so it has to cut itself on at 90 degree. So this is important. Why these are cutting at 90 degree? Because the direction of these roads are north south and east west, so this has to cut itself at 90 degree. And these are the other streets that run parallel to the main street. So this is the first east-west street, this is second east-west street, this is third east-west street, that is main road as well, and the fourth east-west street and the fifth east-west street. Likewise, this is first north-south street, second north-south street, and this is the third north-south street, that is main road, and fourth north-south street and fifth north-south street. So when these two streets cut each other, we call it, this is 1, 1. This is 2, 1. This is 3, 1. So this is third street of the north south and the first street of the east west. So if you have been told to go to the crossing of third fourth street, sorry, I have done something wrong here. Okay, 2, 2. The naming convention is like this. Here there is no 0, right? This is only the naming convention that we are following. Here there is no origin or something. We are not calling this point as origin, right? The naming convention says that the 2 2 crossing will be the crossing of the second north south street and second east west street. So if we say 4 2 crossing, go to 4 2 crossing. So where we have to go? You have to go to the fourth north south street and second east west street. So first one is the road number of north south and second one is the road number of the east west direction, right? So if we say what is this crossing? So which two roads are crossing each other? This is second north south and fourth east west. So this is 2 4 crossing. We can say this is 2 4 crossing. So can you see there are so many crossings in the city, and with number you can uniquely identify each of the crossing. So if it didn't have this naming convention, then how will you say somebody to go to the 4-2 street, 4-2 crossing? How will you say something to go to the 3-4 crossing, right? And we can even by naming these roads, the person can easily identify. First, he has to go to the third road, then he has to go to the fourth east-west street. So he will reach to 3-4 cross street. So the question problem is asking how many cross streets can be referred to as 4-3. So you can see the fourth north-south street and third east-west street. There is only one such crossing where fourth street and third street cross each other, because fourth street cross to first street here, second here, third here. So there is only one crossing. And how many cross streets can be referred to as 3-4? So 3-4 means the third north-south street and fourth east-west street. So you can see the use of the coordinate geometry in city planning. In city planning, you can name the crossings. So this is the use of coordinate geometry in a plane, and how can you locate the points in a plane. So let us come to Cartesian system. So whatever we were studying till now, that is Cartesian system only. We already know number line, and number line is the use of a unit distance. We say that one unit distance represent one unit, one. So if we say the 0 to 1 unit distance is 1, then 3 unit distance represent 3. The point in the positive direction at a distance r from the origin represents number r. So if you go in the positive direction, we call it the positive numbers, and if we go in the negative direction, that is left hand side of the origin, so those numbers we say as negative numbers, negative distance from origin. So that is the number line, and number line is in only one dimension, in only one direction, right? So with number line we know only one direction, right? And if we take two number line and cross each other at origin at 90 degrees, then we have we can find all the points in the plane with two number line. With only single number line, with only single number line, if you say the point is three units away from origin, 3 units in the positive direction, so you can find that point on a line here. But if you say that the point is 3 units away from origin in a plane, so that point can be 3 units away from origin in x direction. So that point is can be any point here, right? So all these points are 3 units away in x direction. So we cannot uniquely identify the point in a plane with only one number line. So we need two directions so that we can uniquely identify a point in a plane. So if we take two number lines crossing each other at their zeros and perpendicular to each other, we get Cartesian system. So from origin, this is the two number lines, right? So this is x-axis and we call this as y-axis. And this is the positive x-axis and this is the positive y-axis. And in the downside, this is negative y-axis. On the left side, this is negative x-axis. And further, we divide the plane in 4 quadrants. When we are talking about the Cartesian system, we must understand we are talking of a plane. So of a plane, the coordinate, we call the plane Cartesian plane or the coordinate plane or the xy plane. You observe that the axis means the plural of the word axis, divide the plane into 4 parts. These 4 parts are called the quadrant or 1/4 part, numbered 1, 2, 3 and 4 anti-clockwise from OX. So the plane consists of the axis and these quadrants. We call the plane Cartesian plane or the coordinate plane or the xy plane. The axes are called the coordinate axis. Okay, so we have divided the plane in 4 quadrants. So where we say a point is in the first quadrant, we say the point is in the third quadrant, we say the point is in the fourth quadrant. So we can imagine where the point is with respect to the origin. So in the first quadrant, both x and y are positive. In the second quadrant, x is negative but y is positive. In the third quadrant, x is also negative and y is also negative. And you must understand this quadrants goes anti-clockwise like this. These quadrants are located anti-clockwise from OX. So this is first quadrant, second quadrant, third quadrant and fourth quadrant. Anti-clockwise, remember this. This is anti-clockwise. So there is a point P. How will you locate the point? This is 4 units away in the x direction and 3 units away in y direction. So we can find the unique point 4, 3. And x coordinate of a point is also called abscissa. So this is a new term, abscissa. So x coordinate is called abscissa and y coordinate is called ordinate. So when we say the point is 4, 3, the x coordinate is 4 and the y coordinate is 3. So we generally write the point in the convention x, y. So the first number is is the x coordinate and the second number is y coordinate. And x coordinate is also called abscissa and y coordinate is called ordinate. Y coordinate is called ordinate. So Pn is equals to OM equals to 4. So if to locate this point, you have to see how much distance it is from y-axis. So distance from y-axis is the coordinate of x. You need to understand this. And how much this is from the x-axis. How much distance away it is from the x-axis. That is in the y direction. In the y direction it is 3 units away and in the x direction it is 4 units away. Okay, so with reference to this figure, we will be completing the statements. The abscissa and ordinate of the point B. So this is the graph, and we know the abscissa is x coordinate and ordinate is y coordinate. And what is x coordinate? X coordinate is the distance in x direction and y coordinate is distance in y direction. And when we say distance in x direction, it is distance from y axis. Just see and try to imagine what I am telling. When we say x coordinate, that is distance in x direction, this distance is actually the distance from y axis. Distance from y axis is x coordinate, right? So the distance in x direction is x coordinate and distance in y direction is y coordinate. And x coordinate is called abscissa and y coordinate is called ordinate. The abscissa and ordinate of the point B are, so B is 1, 2, 3, 4 points away, 4 unit distance away in x direction and 1, 2, 3 unit away in y direction. So we say 4 units away in x direction and 3 units away in y direction. So this way we can find the point B. So the abscissa is 4 and ordinate is 3. X coordinate is 4, y coordinate is 3. Hence the coordinates of B are 4, 3. So this is the way we write the coordinate 4, 3. X coordinate first comes the x coordinate, next comes the y coordinate. The x coordinate of the and the y coordinates of the point M are, you can try to do it yourself. The point M is 3 units away in the negative x direction and 4 units in the positive y direction. So the coordinates is -3, 4. X coordinates and the Y coordinates of the point L are. So L is in the negative X direction and negative Y direction. So this is 5 units away in the negative X direction and 4 units in the negative Y direction. So the coordinate is -5, -4. The X coordinate and Y coordinate of the point S are, so the point S is in the positive X direction and negative Y direction. So positive X direction it is +3 unit, and in the negative Y direction it is -4 unit. So the coordinate of S is 3, -4. So we have come to the exercise 3.2. Do it yourself and come back. Write the answer of each of the following question. What is the name of horizontal and vertical lines drawn to determine the position of any point in the Cartesian plane? Right? Horizontal and vertical lines drawn to determine the position of any point in the Cartesian plane. So to find the position of any point, we take the help of two axes. One is horizontal, one is vertical. So what is called horizontal? This is horizontal x-axis, and this is vertical y-axis. So to determine the position of a point in a plane, we use x-axis and y-axis. So the name of the axes are x-axis and y-axis. Horizontal line is x-axis and vertical line is y-axis. What is the name of each part of the plane formed by these two lines? So we have divided the plane into 4 parts, where x and y both are positive, that is quadrant 1. So this is wrong, this is wrong, this is wrong. So the where x and y both are positive, that is quadrant 1. Where x is negative, y is positive, is quadrant 2. Where both x, y is negative is quadrant 3. And where x is positive and y is negative is quadrant 4. So we have to move anti-clockwise from x-axis in this direction. So if you go anti-clockwise, you get the quadrant 1, quadrant 2, quadrant 3, quadrant 4. Remember the term anti-clockwise. Write the name of the point where these two lines intersect. So these two lines intersect at origin. We say that point 0, 0. So x is also 0, y is also 0. From where x-axis and y-axis both are starting, so that is the origin. The point of intersection of x and y-axis is origin. See figure and write the following. So you try to do it yourself. See the figure and write the following. Coordinates of B. Where is B? It is in the second quadrant. It is in the -5 units away in the x direction and 2 units away in the y direction. So the coordinates of B is -5, 2. The coordinates of C is 5, -5, because in the positive x direction it is 5, negative y direction it is 5, so -5. The point identified by the coordinates -3, -5. So -3, -5 will be in the quadrant 3, third quadrant. So both are negative, so it will be in the third quadrant. So -3, -5 is this point E. The point identified by the coordinates 2, -4. So first you see where this will be located. 2 and -4. X is positive, y is negative. So this will be fourth quadrant. Right? So 2 in the x direction and -4 in the y direction. The abscissa of the point D. Abscissa is the x coordinate. Abscissa is x coordinate and ordinate is y coordinate. So the where is the point D? Let us see the point D. D is in the first quadrant and D is the abscissa, that is x coordinate is 6. In the x direction it is 6 and in the y direction it is 2. So abscissa of the point D is 6. The ordinate of the point H. Where is the point H? H is in the third quadrant, and in the third quadrant the ordinate of the point is the y coordinate. So in the y direction it is -3. the coordinates of the point L. The point L is on the y-axis. You can see this point L. So L is on the y-axis, and distance from in the x direction is 0, and distance in the y direction is 5. So the coordinates of L is 0, 5. And where is the L located? It is neither in first quadrant nor in second quadrant. It is on the y-axis. The coordinates of the point M. Where is M? M is on the negative direction, the negative direction on x-axis. So this is minus 3 units away in negative direction, negative x direction, and it is 0 distance away from y-axis. So in the y direction it is 0, and in the x direction it is minus 3. So the coordinate is minus 3, 0. Plotting a point in the plane if its coordinates are given. So in the same way we can do all these exercise. Locate the points 5, 0. 5, 0 is in the x direction 5, and y direction is 0. So that will be on the x axis. And 0, 5. So in the x direction it is 0, and in the y direction it is plus 5. So it will be on the y axis. 2, 5. So 2, 5 is in the x direction, it is 2, x coordinate is 2, and in the y direction it is 5. So 2, 5 will be in the first quadrant, and 5, 2. 5, 2 will also be in the first quadrant, but in 5, 2 will be in the x direction it is 5, and the y direction it is 2. So that is 5, 2. Minus 3, 5, that is x is negative, y is positive, that is second quadrant. So minus 3 plus 5. Minus 3 minus 5 point, that will be in the third quadrant. 5 minus 3, that will be in the fourth quadrant, because here x is positive and y is negative. And 6, 1 in the Cartesian plane. So 6, 1 will also be in the first quadrant. X direction 6 and y direction 1. Exercise 3.3. In which quadrant or on which axis do each of the points minus 2, 4, 3, minus 1, minus 1, 0, 1, 2, and minus 3, 5 lie? Verify your answer by locating them on the Cartesian plane. So both positive, minus 2, 4, x positive, x negative, y positive, this is second quadrant. 3 minus 1, so x positive, y negative is fourth quadrant. Minus 1, 0, minus 1, 0 is on the negative x-axis, so it is not in on the coordinate in the quadrant. We say it is on the x-axis. Minus 1, 0 lies on the x-axis. It is not in the neither in second quadrant nor in third quadrant. It is on the x-axis. And 1, 2 lies in the first quadrant. Both are positive, so it is first quadrant. And minus 3, 5, x negative, y positive, so that is second quadrant. Plot the points x, y in the given table on in the plane, choosing suitable units. So you have to use a graph paper to plot it, or you can make yourself some unit. You can take unit dimension and make a graph and plot these points. I have taken help of Excel to plot all these points. So xy, that is minus 2, 8. You can use your maths textbook and you can try to do it yourself. Without graph paper also you can do. You can divide the point like this is 1 centimeter is 1 unit, 2 centimeter is 2 unit. Likewise you can do minus 1, minus 2, and then you can locate the point 1 and 3 somewhere. If it is 1, 2, 3. So like you can further divide, like 1 is 0.5, 0.25. So you know from the number line system you know how to locate point 1.25. So where will be 1 minus 1.25, right? So y is, this is -1, this is -2. So midpoint of this will be -1.5, and midpoint of -1.5 and 1 is -1.25. So this is how you can locate the points. So -1.0 and -1.25. X is 0 and y is -1.25. And here x is, so let us start. The first point is -2, x is -2, x is -2, and y is 8. So this is the point, the first point. X is -1, x is -1, and y is 7. So this is the second point, right? So this is the x -1 and y is 7. X is 0, y is -1.25. So this is the third point. X is 1 and y is 3. X is 1 and y is 3. So this is the point. X is 1 and y is 3. And 3 minus 1, right? So this is the point, 3 minus 1. In the figure you might not be able to see where is the 0 line, right? This is the 0 line. This is the 0 line. Somewhere, okay. There might be some error, but okay. So the x is 3 and y is -1. You can locate on this point also. Like x is 3, here somewhere 3. So you go 3 and this 1. So where it will be? This point. This will be 3, 1. 3 and -1, sorry, 3, and in the negative y direction that is -1, so 3 -1. In the x direction is 3 and y direction is -1. So you can plot all these points on a graph paper. We have come to the end of the chapter, and this is the summary. I will read it out once. So we have studied the following points. To locate the position of an object or a point in a plane, we require two perpendicular lines. So this is important, two perpendicular only, right? And if we take like this, so if these lines are not perpendicular, so it will be very difficult to locate the point if these points are not perpendicular, right, in a plane. So it is very easy to do this when the lines are perpendicular. So to locate a point in a plane, we have to take two perpendicular lines. So this is a very important mathematical concept, right? Why this has to be perpendicular? Because the movement in this direction and movement in this direction are independent. If you move like this, then you have moved in two directions. You have moved in this direction and this direction. If you moved like 1 unit here and 2 unit here, so total and actual movement is this direction. So you have actually moved in root 2 root 5 distance. So in your higher classes, you will appreciate this point, that why this has to be perpendicular. So to locate the position of an object or a point in a plane, we require two perpendicular lines. One of them is horizontal and other is vertical. The plane is called the Cartesian or coordinate plane, and the lines are called the coordinate axes. So this is the definition. Like we tell it, Cartesian plane, coordinate plane, and the lines are the coordinate axes. The horizontal line is called the x-axis and the vertical line is called y-axis. The coordinate axis divide the plane into four parts called quadrants. The point of intersection of the axis is called the origin. The distance of a point from the y-axis is called x-coordinate or abscissa, and the distance of the point from x-axis is called y-coordinate or ordinate. So this is what I was talking about. Distance of the point from y-axis is x-coordinate. You must understand this. Distance is from y-axis, then that is x-coordinate, right? So distance from y-axis, right, or distance in x direction. So that is same. Distance in x direction or distance from y-axis, and that is called abscissa. If the abscissa of a point is x and the ordinate is y, then x, y are called the coordinates of the point. The coordinates of a point on the x-axis are of the form x0, and that of the point on the y-axis is 0, y. So on the x-axis y is 0, on the y-axis x is 0. So on the y-axis, all the points on the y-axis x is 0. All these points x is 0. So all these points are 0, y. And all the points on the x-axis, the x this is x0, because y is always 0 on the x-axis. The coordinates of the origin are 0. The coordinates of a point are of the form plus plus in the first quadrant. That is what I was talking. In the first quadrant, both are positive. In the second quadrant, x is negative, y is positive. In the third quadrant, both are negative. In the fourth quadrant, x is positive, y is negative. Very simple. Where positive denotes a positive real number and negative denotes a negative real number. Okay, so if x not equals to y, then xy is not equal to yx. Let us see what is xy and yx. So we say 1, 2, 3 and 1, 2. 1, 2, 3. So let us say the point 2, 3. Sorry, this point is 3, 2. X is 3 and y is 2. Xy. And where is the point yx means 2, 3, right? This is 2, 3, right? So we can see 3 and 3, 2 and 2, 3 are not the same point, right? If x not equals to y, then xy is not equals to yx, and xy is equal to yx if x is equal to y. So we have come to the end of the chapter. Thank you for watching. Have a good self study time. Thank you. Bye bye.